In this video, we will learn about humidity. Humidity is a very important topic in HVAC. First, we need to understand what humidity is. Our atmosphere is a mixture of 78% nitrogen, 21% oxygen, 0.9% argon, and a small amount of water vapor. The amounts of nitrogen, oxygen, and argon remain constant, and their values do not change. However, the amount of water vapor varies depending on the place and the weather. This water vapor present in the atmosphere is what we call humidity. Air without water vapor, containing only nitrogen, oxygen, and argon, is called dry air. Air that has water vapor mixed in it is called moist air. However, in practice, dry air does not exist anywhere. There will always be some amount of water vapor mixed in the air. First, let's understand how the temperature of water decreases through evaporation. Let's take a bowl of water. The water temperature is 30 degrees Celsius, and the atmospheric air temperature is 25 degrees Celsius. In the water at 30 degrees Celsius, the high-energy molecules absorb heat from the water and evaporate from the water's surface. During this evaporation process, the water vapor takes away some heat from the water, causing the water temperature to decrease. As this continuous evaporation takes place, the water temperature will gradually decrease until it equals the atmospheric temperature. The water vapor that evaporates during the evaporation process mixes with the atmospheric air. This mixed water vapor is what we call humidity. There are two types of humidity: absolute humidity and relative humidity. Absolute humidity is measured in grams per cubic meter. Relative humidity is measured as a percentage. However, what we commonly use is relative humidity. Normal humidity levels typically range from 30% to 50% in indoors, and 30% to 60% in outdoors. High humidity levels are considered to be above 60%, while low humidity levels are below 30%. When the humidity level in the atmosphere is high, the water in the bowl tries to evaporate and mix with the atmosphere. However, because the atmosphere already contains a lot of water vapor, so the water in the bowl will evaporate slowly. Therefore, the water temperature will decrease at a slower rate. Here's a perfect example. Imagine a dry sponge. This dry sponge represents the dry air in the atmosphere. As we add water drops to the sponge, it absorbs and stores them. The water we add represents humidity. When the sponge becomes saturated, it cannot absorb any more water. Similarly, when the humidity level in the air is high, it becomes difficult for additional water to evaporate. Let's see how high humidity levels can affect human body temperature and cooling towers. Our bodies constantly release sweat through tiny pores on our skin. This sweat evaporates from our skin, taking away heat from our body and mixing with the air. This process helps maintain our body temperature at a normal level. However, when the humidity level in the atmosphere is high, the air cannot hold any more water vapor. Therefore, the sweat cannot evaporate, and it remains on our skin. This prevents our body temperature from decreasing, and makes us feel sticky, due to the sweat remaining on our skin. This is why weather reports often say, it feels like 30 degrees Celsius, even when the actual temperature is 27 degrees Celsius, due to the high humidity. This is how high humidity affects our body temperature. Let's understand how this affects cooling towers. In a cooling tower, water from the chiller's condenser falls onto the cooling tower fills and slowly travels downwards, then returning to the chiller's condenser through the return line. This water is used to reduce the temperature of the refrigerant in the chiller. The fan motor in the cooling tower draws air upwards through the fills. As the air passes through the fills, some of the water evaporates and is carried away by the air, cooling the water. This cooled water is then returned to the chiller. However, when the humidity level is high, only less water evaporates from the cooling tower, and the water returning to the chiller is not cooled as effectively. This reduces the cooling tower's efficiency. Since the water entering the condenser is at a higher temperature, due to the high humidity, it cannot cool the refrigerant as effectively. This leads to an increased load on the chiller. This is how high humidity affects the overall process of a chiller plant. These are just some of the problems caused by high humidity. Besides these issues, high humidity can cause many other problems. For example, high humidity can lead to increased energy consumption, mold growth inside homes, damage to wooden components, corrosion of metal components, and exacerbation of asthma and allergies.